A non-uniform rod AB of length 1.2 meters and mass 25 kilograms is freely suspended by two strings as shown in the diagram. We want to find the tension in each string and the distance of the center of mass of the rod from A. This end is A, and this one we'll call B. The weight does not necessarily act at the center, since we're told the rod is non-uniform. So the weight of 25G is here, and we'll call the distance from A X. We have two strings suspending the rod, and we'll call the tensions in them T1 and T2. Let's begin by resolving the tension forces. Tension 2 has a component in this direction, which will be T2 times the cosine of 45 degrees. Note this side is adjacent to the 45 degrees. Adjacent over hypotenuse means cosine. Once we know this is the cosine, the component in this direction must be the sine. So here we have T2 sine 45 degrees. Doing the same thing for the T1, this component will be T1 cos 60, and this component will be T1 sine 60. We can ignore T1 and T2 once we've put the components onto the diagram, since the components have the same effect. If we're in equilibrium, forces to the left must be equal to forces to the right. That's because there's no horizontal acceleration. So T1 cos 60 must be equal to T2 cos 45 degrees. It's also the case we must have equilibrium vertically. So these two components must equal this force. T1 sine 60 plus T2 sine 45 must be equal to 25G. It's also the case that if we take moments about any point, the resultant moment must be zero. Let's take moments about A. So this is our pivot, and this component will have no turning effect because their distance from the pivot is 0. The same is true for this component. Its line of action acts back through the pivot. So only this component and the weight will have a turning effect. This one will turn us clockwise and this one anti-clockwise, and they must balance out. So 25G multiplied by the distance from the pivot, which is x, must be equal to T2 sine 45 times its distance from the pivot, which is 1.2. What we've formed is three simultaneous equations. One gives us that T1 is equal to T2 times the cosine of 45 degrees divided by the cosine of 60 degrees. We could substitute this into number 2. So replace this T1 with the expression involving T2. T2 cos 45 divided by cos 60 instead of the T1 multiplied by sin 60 added to T2 sin 45 will be equal to 25g. We have a common factor of T2 on this side. Open a bracket and we have cos 45 times sin 60 divided by cos 60 plus sin 45 is equal to 25g. T2 then is going to be this divided by the contents of the bracket. And this gives us 126.8 newtons, correct to 1 decimal place. We can now come back to this expression to work out the value of T1. T1 is going to be T2 times the cosine of 45 degrees divided by the cosine of 60 degrees and this is 179.4 newtons. We can now use equation 3 to find x. 25 times 9.8 times x is equal to T2, which is 126.8, times the sine of 45 degrees times 1.2. So x is going to be 126.8 times sine 45 times 1.2 divided by 25 times 9.8. And this gives us 0.439 meters, correct to 3 significant figures.